Hello, my name is David Carr and today I'll be showing you how to turn semi-precise plastic parts on a wood lathe. This was something that I found particularly useful during my time at university, as it allows you to quite easily prototype complex and organic shapes on the lathe. The first stage is simply to cut a cylinder of Perspex from a block that's deep enough to accommodate the part that you want to create. Once you've cut the cylinder, you'll just need to key up the top and bottom surfaces that will need to be glued into the lathe. Today I'll be showing you how to do this simple hollowed cone, as it presents quite a few of the different techniques that we use on the lathe. To mount the billet to the face plate, we simply need to recess an area large enough to accommodate the billet. The recess only needs to be sank in by a couple of millimetres, and I would advise making it just slightly larger than the billet itself. When it comes to glue the billet into place, the excess glue that comes up the shoulder of the billet should form quite a good socket bond. The first job to do on the lathe is to parallel turn the sides to a true diameter. Bear in mind the final part you want to end up with and check on the diameter as you're turning it down. To do all of the plastic turning, I'll be using a skew chisel. This tool can be used in a similar way to a knifing tool on a metal lathe. With this tool you can also track the point into the part to allow you to achieve very straight edge cuts down the part. Once the billet's been turned to the correct external diameter for the entire part, we can now look at achieving the cone shape. To do this precisely, we first need to turn a shoulder into the face of the part. When you've achieved the correct diameter, this then gives us two fixed points to work across from. Now it's just a simple matter of gradually reducing the side angle until it matches up between the 2 points. Once you've trimmed down the external of the billet and it's matching in with your dimensions, it's now time to start on the internal. Take particular care whilst you're doing this and work slowly, bearing in mind the centre of the billet will be turning a lot slower than the externals were. To counter this, you may need to alter the variable speed on the lathe. Gradually start to create a hollowing that the tool can then be seated in to cut further. I'd also advise removing swarf as it's created, otherwise this can jam within the part and cause problems later on. Because we're working in clear Perspex, as we start to work inside of the billet we'll get a lot of visual distortion. Because of this, I'd advise checking with a vernier gauge to determine the wall thickness that we're working with. After you're happy with this, you can continue on hollowing out the part. Because this is completely hollowed, we can work with the edge of the skew chisel against the external face. This should allow us to gradually cut along whilst maintaining the same side angle and allow us to gradually hollow out the part. Once you're happy with the basic form of the profile, you can then go around, retrim and touch up certain parts of the profile. Once all this has been done, you'll then be ready to sand the part on the lathe. When sanding on the lathe, fully remove the tool post so that everything's out of the way of the billet. This will prevent any snags whilst you're working. You can then proceed to work with different grits of sandpaper on the billet. However, because of the organic shapes, you may need to make up tools so that you can get in with the sandpapers. When sanding on the lathe, you're only looking to remove most of the deep marks and scratches left by the cutting process. If you proceed on with too fine of a grade, you can end up with the sandpaper clogging and then burning into the Perspex. After you're happy with the general surface finish of the part, it's now time to part it away from the faceplate. Once you've got the part off the lathe, you can now check over the dimensions and sand it back as needed. You'll most likely need to re-sand where you've parted away, as this will usually leave a ragged edge on the internals. Sand any faces that you've treated again with progressively finer grits of wet and dry paper. With hollowed turnings, you may find that you're left with track lines on the internal of the part. These will need to be sanded back, and do this just in the normal way with progressively finer grits of wet and dry paper. Once all of the marks have been removed, then proceed to use the wet and dry paper wet to achieve a good general surface finish over the entirety of the part. Once you've got the part up to this stage, it's now ready to be polished. It's personal preference as to which polish you use, however work it in the same way with a cotton cloth and vigorously rub around all of the contours of the part. Continue in the normal way of rubbing polish on and back off the part and then buffing it up on a clean cloth. As you work progressively further, this should allow you to achieve a near lens finish. To create higher complexity and more technical parts, you can first laser cut billets of Perspex, which can then be laminated up and turned on the lathe using the same process. This is a technique I've used numerous times whilst I was at university, and it allows you to rapidly create semi-accurate parts to a very high level of finish for both prototypes, cosmetic models, and in this case film props. Here are a few other examples of places where I've used Perspex turning. As you can see, you can create a broad range of other finishes which are quite useful when prototyping. It's also possible to rapidly create parts which can then be post-processed on something, for example a laser cutter. This is how I've created the power on and off button on top of my Dremel prototype. The very small speed selector was also created in the same way. These parts have then been spray painted over to create a fully finished cosmetic model.